What if I told you that our galaxy is filled with ghosts? Not the kind you find in haunted houses, but something far more powerful. These are cosmic ghosts, invisible and silent, wandering through the vast emptiness of space. They are rogue black holes, untethered from any star or galaxy, drifting alone through the darkness. Imagine an object with the mass of a star, or even millions of stars, squeezed into a space smaller than a city. Now imagine that object hurtling through the Milky Way, completely unseen. This isn't science fiction. It is a reality that astronomers are just beginning to uncover, a hidden population of cosmic wanderers that could number in the millions right here in our own cosmic backyard. The scale of this hidden population is truly mind-boggling. Scientists estimate that there could be as many as 100 million rogue black holes roaming the Milky Way alone. Think about that for a moment. For every star you can see in the night sky, there could be countless invisible predators drifting silently between them. These are not just the small stellar mass black holes born from dying stars. The galaxy could also host intermediate mass black holes, and perhaps even a few exiled supermassive ones, each a ghost from a long-dead galactic core. This unseen majority makes up a significant part of our galaxy's total mass, yet we have only just begun to search for it. Before we can chase the ghosts, we must first understand what they are. So what exactly is a black hole? Imagine taking something with a lot of mass, like our sun, and squeezing it down into an impossibly small space. For the sun, this would mean crushing it into a ball just a few kilometers across. The gravity of this incredibly dense object would become so powerful that it would warp the very fabric of space and time around it. This creates a cosmic prison from which nothing can escape. Not all black holes are created equal. The most common type is the stellar mass black hole. They are born from the spectacular death of a single giant star, triggering a cataclysmic explosion known as a supernova. The second, much larger type is the supermassive black hole. These are the true giants of the cosmos, behemoths with masses ranging from millions to billions of times that of our sun. So how do you unmoor a cosmic anchor? A galactic merger. They're dynamic and often collide with one another into a cosmic dance that ends in a spectacular fusion. Their central supermassive black holes begin a slow, spiraling journey toward each other, when a third galaxy joins the fray. Is the perfect recipe for a galactic slingshot, can be ejected with tremendous force. Supermassive black holes are not the only ones that can be kicked out of their homes. The supernova explosion. This explosion cannot be perfectly symmetrical. The uneven force gives the newly formed black hole a tremendous kick. If the star was part of a binary system, this kick could easily break it free from the gravitational grip of its companion star. A projectile fired into the galactic wilderness. They often find pulsars moving at very high speeds relative to the stars around them. There is another, more ghostly way for a black hole to become a rogue. Our Milky Way is a cannibal. Like all large galaxies, it grew to its current size by absorbing or eating smaller dwarf galaxies over billions of years. We can see the stretched out stellar streams of dwarf galaxies that are currently being torn apart by the Milky Way's immense gravity. Now imagine what happens to the central black hole of one of these dwarf galaxies. But the central black hole is much more resilient. The black hole is left to wander through the Milky Way's halo, a cosmic orphan. So how do you find an object called gravitational microlensing? Bend the fabric of spacetime, acts like a powerful invisible magnifying glass. Imagine a distant star shining brightly. Its gravity will bend the starlight around it. Making the star appear to brighten temporarily is a key signature of a microlensing event. Another revolutionary tool in the hunt for rogue black holes doesn't rely on light at all. These disturbances are called gravitational waves. When two massive objects, like black holes or neutron stars, spiral into each other and merge, they create powerful disturbances in spacetime. The final combined black hole that results from such a merger is given a powerful kick from the gravitational waves themselves, which are not always emitted symmetrically. Furthermore, future gravitational wave observatories, like the Space-Based Laser Interferometer Space Antenna, or LISA, will be sensitive to much lower frequency waves. These are the kinds of waves produced by the mergers of supermassive black holes at the centers of galaxies. the very events that can create rogue supermassive black holes through the Galactic Slingshot mechanism. Lisa will be able to detect the slow, long dance of these giants as they spiral together, potentially even catching the moment one is ejected. It will open a new window onto the most chaotic processes in the cosmos, listening for the echoes of events that create the universe's largest wanderers. Imagine a rogue black hole. The consequences would be catastrophic. The black hole's immense gravity would arrive long before the object itself was visible, would be thrown into chaos. Any planets orbiting these stars would have their fates sealed. They would be ripped from their suns, sent either into the freezing void. The most terrifying part of such an encounter is its stealth. So what if one of these cosmic wanderers passed near our own solar system? If a stellar mass rogue black hole were to drift through the Oort cloud, it would send a shower of comets, potentially millions of them, hurtling towards the inner solar system. Such an event could trigger mass extinctions, fundamentally changing our planet's future. The orbits of the outer planets. Their stable orbits protect Earth from many asteroids and comets. Jupiter, in particular, could be pushed into a new, more elliptical orbit. The very existence of our stable solar system, which has allowed life to flourish for billions of years, is a testament to our good fortune. While rogue black holes are agents of destruction, they are also, in a strange way, creators. It doesn't just destroy, it can also steal. A collection of dark, cold worlds orbiting an invisible master. These captured planets, known as planets or black hole planets, and potentially sustain liquid water oceans beneath their icy shells, triggering the formation of new stars. Where destruction and creation are really just two sides of the same coin. Why do we search for these dark wanderers? The answer lies in a fundamental part of what makes us human, our unquenchable thirst for knowledge. We look up at the night sky and we don't just see points of light, we see a grand cosmic puzzle. Rogue black holes represent a true frontier of modern astronomy. These objects are extreme laboratories for the laws of physics. Ultimately, we search for rogue black holes because it is in our nature to explore the unknown. To hunt for ghosts, we need to build better eyes. Future projects like the Vera C. Rubin Observatory in Chile are designed to do just that. When it comes online, this observatory will scan the entire southern sky every few nights. This will increase our chances of catching a rogue black hole in the act by orders of magnitude. The Nancy Grace Roman Space Telescope, set to launch in the coming years, the proposed Laser Interferometer Space Antenna, or LISA, will be a game changer. It will consist of 3 spacecraft flying in a triangular formation. These future observatories are our new tools for exploring the dark. In the end, every rogue black hole we find is more than just a scientific curiosity. It's a storyteller. A stellar mass rogue tells a story of a giant star that lived and died. A more massive rogue, one in the intermediate mass range, tells a different story. It might be the ghost of a dwarf galaxy. These black holes are the last surviving witnesses to the construction of the Milky Way. A truly supermassive rogue, a giant exiled from its galactic throne. We're piecing together the grand, sprawling, and often violent story. Our journey into the world of rogue black holes brings us to the edge of human knowledge. The quest to find them is more than a scientific endeavor. With each new discovery, we are pushing back the darkness bit by bit. These cosmic phantoms are both a potential threat and a profound wonder. Their study forces us to confront the deepest questions as we stand on this precipice of discovery, and as we continue to peer into that void, we can be sure that the universe will have many more surprises waiting for us, beckoning us ever forward into the endless frontier.